Hey there, science fans! Ever wonder how we can share information online super securely? Today we're diving into something called Distributed Ledger Technology, or DLT for short. Imagine a special kind of digital notebook. This isn't just any notebook, mind you. It's a notebook that many people can have a copy of, all at the same time. Everyone with a copy sees the exact same entries, updated together. It's like a shared diary, but for important data, and everyone is on the same page, literally. This is the big idea behind DLT, making information open and trustworthy. Now, blockchain is a fantastic and very popular type of DLT. Think of DLT as the whole concept of shared digital record keeping. Then, blockchain is a specific, very clever way to do that record keeping. It organizes information into blocks and then links these blocks together to form a chain. Get it? Blockchain. It's a system designed from the ground up to be incredibly difficult to tamper with. Once information is added, it's there to stay, visible to everyone involved. It's a powerful tool for transparency and making sure data is accurate. Why is this so revolutionary, you ask? Well, consider this. In many traditional systems, one person or one central computer holds all the important information. That single point can be a weakness. If it fails, or if someone changes the data there, problems arise. DLT, and specifically blockchain, changes that game entirely. By distributing the information and the power, it makes systems more robust. There's no single point of failure. It's about creating trust through shared, verifiable information without needing a middleman to vouch for everything. So, let's recap this cool concept. DLT is the broad idea of a shared, synchronized, and spread out database. Blockchain is an innovative way to implement DLT using linked blocks of data. It's designed to be secure, transparent, and resistant to unauthorized changes. This technology is not just a fad, it's a fundamental shift in how we can manage and trust digital information. It's science in action, solving real-world problems of trust and security in the digital age. Pretty neat, huh? Alright, let's get into the nuts and bolts, or rather, the blocks and chains. What exactly is a block in a blockchain? Imagine a digital container like a sturdy box. This box is filled with information. This information could be records of transactions, like who sent what to whom and when it happened. Or it could be other types of data, like details about a product's journey or steps in a contract. Each block can hold a certain amount of this information. Once a block is full, it's ready to be added to the chain, so we have these blocks full of data. How do they become a chain? Well, it's quite clever. Each new block, once it's verified and ready, gets linked to the previous block. This linkage is done using cryptography. That's math-based security. Each block contains a unique code, like a digital fingerprint from the block before it. This creates a strong, unbreakable connection. So, you have block 1, then block 2 is linked to block 1, block 3 is linked to block 2, and so on. It forms a chronological and unalterable sequence. Science. Now, let's talk about some core principles that make blockchain so special. First up, decentralization. This is a big one. Unlike traditional databases that are stored in one central place, a blockchain is typically spread across many computers in a network. No single computer or entity controls the entire thing. This means if one computer goes offline, the blockchain keeps on running. It's power to the network, not to a single point. This distribution makes it incredibly resilient and fair. Then there's transparency and immutability. Transparency means that for public blockchains, anyone can view the history of transactions on the ledger. It's all out in the open. For private blockchains, this transparency is usually limited to the approved participants. Immutability means that once data is recorded on the blockchain, it's extremely difficult to change or delete it. Think of it like writing in stone, but with digital technology. Each block reinforces the security of the previous ones, making the entire chain incredibly trustworthy. Isn't that amazing? Not all blockchains are created equal, and that's a good thing. There are different types, designed for different needs. First, let's look at public blockchains. Think of these as open to everyone. Anyone can join the network, participate in verifying transactions, sometimes called mining, and view the entire history of the ledger. Bitcoin and Ethereum are famous examples. They are highly transparent and truly decentralized, meaning no single entity has control. This openness is fantastic for things like cryptocurrencies or community-driven projects. Next, we have private blockchains. These are quite different. Imagine a members-only club. A private blockchain is controlled by a single organization. That organization decides who can join the network, who can see the data, and who can make changes. This offers more privacy and control than a public blockchain. Businesses often prefer this type for internal operations, like managing their supply chain or internal records, where confidentiality is key, but the benefits of blockchain security and efficiency are still desired. It's a more controlled environment. Then there's a middle ground: consortium blockchains. Think of this as a group project where several organizations come together. Instead of one organization being in charge, like in a private blockchain, or no one being in charge, like in public ones, a consortium blockchain is governed by a pre-selected group of participants. For example, a group of banks might create a consortium blockchain for faster and more secure interbank transactions. Or several companies in an industry might collaborate to track goods. It's about shared control and shared benefits. So where are these amazing blockchains being used? The applications are exploding. In business, companies are using blockchain to track products through supply chains, ensuring authenticity and reducing fraud. Imagine knowing exactly where your food came from. In banking, it's being explored for faster, cheaper international payments and for streamlining trade finance. Healthcare is looking at it for securely managing patient records, giving patients more control over their sensitive data, while ensuring its integrity. The possibilities are truly vast and exciting. How does blockchain keep all this data so safe and sound? One of the biggest secrets is cryptography. Yes, cool, complex math. Cryptography is used to secure the transactions and the links between blocks. Each block, as we mentioned, has a unique digital fingerprint called a hash. This hash is created using a cryptographic algorithm. If even one tiny bit of data in a block is changed, the hash of that block changes completely. This makes tampering immediately obvious to everyone on the network. It's like a super-sensitive alarm system. This hashing is key to the chain's security. Each block doesn't just contain its own hash, it also contains the hash of the previous block. This is what links them together so securely. So if someone tries to alter an old block, its hash will change. This means the hash stored in the next block will no longer match. This mismatch would cascade down the entire chain, invalidating all subsequent blocks. To successfully tamper with a blockchain, a person would need to recalculate the hashes for the altered block and all the blocks after it, which is incredibly difficult and computationally expensive, especially on a large, decentralized network. Beyond cryptography, there's something called consensus mechanisms. Since many computers hold a copy of the ledger, how do they all agree on which new blocks are valid and should be added? That's where consensus comes in. It's a set of rules that network participants use to agree on the state of the ledger. Think of it like a digital voting system. Different blockchains use different consensus methods, like proof of work, which Bitcoin uses, or proof of stake. These mechanisms ensure that everyone's copy of the ledger stays synchronized and truthful. So what's the big takeaway and the future of blockchain? Blockchain technology is fundamentally about creating trust in digital interactions. It allows people and organizations to collaborate and transact securely, often without needing a central authority. While it started with cryptocurrencies, its potential goes so much further. We're talking secure voting systems, protecting intellectual property for artists, managing digital identities, and even transforming how scientific research is shared and verified. It's still a developing field, but its importance is growing every day. The future of secure, transparent, and decentralized systems looks bright, all thanks to the power of blockchain. Science is all around us,